solution. This time, I used 27.8 grams of iron 2 sulfate, also known as ferrous sulfate, and again 100 mils of water. I turned on the stirring and it started to dissolve, but there was a slight yellow color to the solution. Ferrous sulfate.
Пусть даже так будет, все равно смешнит. Знаешь, такое есть? Не смешнит. Как нормально. Эй! Эй! Ты чё? Эй! Потому что не смешнит. Ну как ты чё? Ну чё? Ничего, ничего. Алло, Граш, это что такое вообще? Там что-то опять, короче, не функционирует, что это. Сбросить надо все и так далее. Специально их не слышу. Потому что не становится. Ну, наоборот, Оборотное хождение. Не стареть, что не стареть. Болеет. Болеет. Вот наоборот. Вот это есть. Да, вот это будет. Вот наоборот. Это наше. Да, наоборот. Да. Да, да. А, ну да. Ну нет, он на себе, да. Ну вот, наверное. Куда-то
When it was done, I took away the filter, and I moved on to making my iron 2 plus solution. This time, I used 27.8 grams of iron 2 sulfate, also known as ferrous sulfate, and again 100 mils of water. I turned on the stirring and it started to dissolve, but there was a slight yellow color to the solution. Ferrous sulfate tends to react with oxygen in the air, and this was probably some sort of oxide that had formed. To deal with this, I just added a few drops of sulfuric acid, and you can see that the color quickly disappeared. After stirring it for a few minutes, everything dissolved, and I moved on to the next step. Into a nice 1 liter beaker, I added the ferric chloride solution that I just made, and I turned on the stirring. Then into this, I poured in the ferrous sulfate solution. There was no reaction going on. Here, and I now just had a mixed solution of iron 2 plus and iron 3 plus. I let it stir for like 30 seconds, and then I tested the pH. From this, I saw the pH was around 1, which was perfect. If it weren't, I would have had to add some extra sulfuric acid. The next thing I did was position a separatory funnel just above the solution. Then I carefully filled it up with the 10% ammonia cleaner. When I was ready to get the reaction going, I turned the stirring close to maximum, and I opened up the separatory funnel. Ammonia is a base, so as it was added, the pH slowly increased. There was initially no reaction though, because everything was still quite acidic. However, when the pH was raised to between 2 and 4, the iron 3+ ion started reacting with it to make brown ferric hydroxide. And as more ammonia was added, more ferric hydroxide was made, and the mixture got browner and browner. The original dark yellow-brown color of the ferric chloride also slowly disappeared. Then when the pH got to between 7 and 9, the ammonia started reacting with the iron 2+ ions to make ferrous hydroxide. Very quickly after it formed though, it reacted with the ferric hydroxide to form a mixed iron compound called magnetite.
Нельзя просто так взять и заговорить на английском за 16 часов. One does not simply start speaking English. Привет, меня зовут Алекс Рубанов, и я основатель онлайн-школы английского English. Я приглашаю тебя на свой самый популярный в России вебинар по английскому, который я решил сделать абсолютно бесплатно. И я надеюсь, ты понимаешь, что на английском языке невозможно заговорить ни за 16 часов, ни за день, ни за неделю. Но
Because this reaction was done slowly, with a weak base, fast stirring, and in dilute conditions, the magnetite particles that formed were extremely small. With this method, it's hard to control the exact particle size, but most of them should be nanoparticles. When it comes to making ferrofluids, it's extremely important to have the magnetite particles as small as possible, and you'll see why in a bit. I had to bring the pH of the mixture up to around 10, but by the time it was nearly full, it wasn't there yet. So I had to temporarily stop things and transfer everything to a larger container. Then I just continued the addition, and I kept checking the pH. It eventually got to the target pH of around 10, so I stopped the addition and I took away the separatory funnel. Then I turned off the stirring and I brought in a really strong magnet to help pull the magnetite out of suspension. When most of it had settled out, I used a beaker to pull out the excess water. I continued doing this until I got to a volume of about 700 mils, and then I transferred it back to a beaker. Just for fun, I brought back my magnet and played around with things a bit. The way that it behaved here was almost like a ferrofluid, but it wasn't because none of the particles were stabilized in any way. This meant that most of the magnetite was easily pulled out of solution, and if I left the magnet there, it eventually would have cleared up. In a proper ferrofluid though, the particles are treated, so even if they're exposed to a strong magnetic field for a long period of time, they never separate. So this treatment step was exactly what I had to do next. I cleaned up the beaker with some water, turned on the stirring, and slowly added 25 milliliters of oleic acid. After it was all added, I increased the stirring a bit more, and I turned on the hot plate. The goal now was to slowly increase the temperature until it got to around 90 C. In the last step, I brought the pH up to around 10, which meant that there was an excess of ammonia. So now, the first reaction that was going on was between the oleic acid and that leftover ammonia. This formed ammonium oleate, which unlike oleic acid, was soluble in water. The polar ends of the ammonium oleate were then absorbed to the surface of the magnetite nanoparticles. And as the temperature was slowly increased, the ammonium oleate degraded and went back to being oleic acid. At around 80 or 85 C, I started to notice some clumping, and by the time that it got to 90, everything separated out. The reason this happened was because at this point, the particles were covered with enough oleic acid to make them extremely hydrophobic. After it separated, I heated the solution for 10 more minutes, and then I took it off the hot plate. I dumped off all the liquid, and then I added distilled water to wash it. I did my best to break it up, but it was really oily and all stuck together. I also had to reach in and manually pull out my stir bar, and you can see how nice and dirty it was. However, it honestly wasn't very hard to clean, and I just washed it with some kerosene and maybe a bit of acid. When I felt like I had given the particles a decent enough water washing, I put the magnet to the beaker and poured everything off. This water washing process was then repeated 2 more times. When that was done, I then washed it 3 more times with ethanol to get rid of any excess oleic acid. What was weird was after the first and second washing, it gave me a nice separated powder, but after the third one, everything clumped together again. I'm honestly not exactly sure why I did this. In any case, when it was done, it looked like I lost a decent amount of magnetite in the washings, so I put a magnet under it to pull it all out. I let it sit for about 10 minutes, and then I poured off the liquid and saw that there was a decent amount at the bottom. This recovery, along with the main stuff, was then transferred onto 2 small dishes. Both of them were still full of ethanol, so to dry them, I put them in my vacuum desiccator overnight. By the morning, the ethanol was gone, but they were both still a bit oily. I think this might be because I used way too much oleic acid in the coating process, so the washing steps didn't get rid of it all. In any case, to test it, I took a small piece from the main batch and added a minimal amount of kerosene. Kerosene is a very nonpolar solvent, and it'll hopefully be able to interact with the nonpolar oleic acid that I attached to the surface of the magnetite particles. This should allow the normally insoluble magnetite to be dispersed in the solvent almost as though it was being dissolved. However, it technically isn't getting dissolved, and it's more accurate to describe it as a stabilized colloidal suspension. This coating of oleic acid also helps keep the particles separated, and it prevents them from aggregating together. Ideally, the final result will be a stable suspension of magnetite nanoparticles that can interact with the magnetic field, but still stay in solution. When I felt that it was ready, I went ahead and tested it, and it kind of worked, but the quality was really bad. To be fair though, it did still kind of work, but it didn't look like it was completely liquid, and it also didn't spike at all. I then whipped up a much bigger batch, and it was pretty clear that this was a terrible ferrofluid. However, on the bright side, I thought that it still kind of looked cool. In a good and proper ferrofluid, the spikes looked pretty soft, but here they were really sharp. And the reason for this is that most of my particles were unfortunately aggregating and getting pulled out of solution. I'm not exactly sure why this happened, but there were only 2 real variables to consider. The magnetite particles were either too big, not coated with enough oleic acid, or it was a combination of the 2. After seeing this, I kind of just assumed that my whole process was a total failure. However, before just scrapping what I had and moving on, I went online to try to find a way to salvage it. And in my research, I ended up finding a YouTube video where a guy demonstrated the most high-quality homemade ferrofluid that I had ever seen. He didn't post a proper tutorial or video about how he did it, but he did reply in the comments. I read through all the comments that he made on all 7 of his ferrofluid videos, and they were honestly really helpful. In my opinion, his most important point was that in making ferrofluids, there are 2 major parts. The first is making the coated nanoparticles like you already saw, and the second is purification. The general idea that I got was that it didn't matter how good my process was to make them, I still had to purify out the ones that were too big, or the ones that weren't coated properly. He only gave some really basic details about the purification, but it seemed simple enough, so I decided to try it out. Now going back to what I recovered, I initially planned to test these 2 samples separately. However, after seeing the poor results that I got, I didn't really think this was worth it, and I just decided to combine them. I didn't just straight up mix one into the other though, and I decided to spread them out as evenly as possible across the 2 dishes. Then I took the one on the right and tried to purify it. The reason I was only doing with half the amount instead of the full thing was that I wanted just to make sure I had a backup in case I messed up. Once I got it all transferred to a beaker, I started adding some kerosene. Then I mixed it all around, and I tried to get it to dissolve. I kept adding more kerosene when I felt I needed it, but in general, the goal was to use as little as possible. After stirring for another few minutes, it really didn't look like this beaker was going to be big enough. So I transferred it all to a larger one, and I washed the beaker a few times with a small amount of kerosene. Eventually, something like 95% of it had dissolved, but I used way more kerosene than I expected. There was also some insoluble junk at the bottom, so I poured everything off from this beaker into a new one. Particles that are properly sized and coated dissolve really easily into kerosene, and you don't need much of it at all. So I think the major reason why I had to use so much kerosene here was just that my particles were really bad quality. Just for fun, I tested things out with my magnet, and you can see that immediately a bunch of solids separated out. After seeing this, I realized that I probably could have just used a lot less kerosene and dumped off most of the junk. The good particles should have all just stayed in solution, and I probably could have gotten away using a lot less kerosene. In any case, for the next step, I still had to use the magnet, but this time the beaker was just placed on top of it. It was then left to sit here undisturbed for about 24 hours. The basic idea here was that all the crappy particles would get pulled towards the magnet, but all the good ones would easily stay in solution. So I came back a day later, and I poured off the liquid.
До сих пор делайте это по-старому. 60 секунд, которые ты не забудешь никогда.
Зачем?
Начинаем. Ваша задача просто смотреть на картинки и повторять за мной.
Куда пойдете? Куда пойдешь? Не надо же. Ладно, нет. Видишь? Вот что это у меня это самое? Понимаете, какая ситуация? Надоест просто.
It's no secret that in the past, Square Enix has struggled with game engines, but none more notorious than that of Crystal Tools, a game engine which caused numerous problems for Final Fantasy XIII, Final Fantasy Versus 13,
Ну, наоборот, просто... Да.
and Final Fantasy XIV.
Ну, конечно, надо. Вот это он есть. Вот это я говорю.
Okay, so today, I'm going to be doing something that I think is kind of gross. To get started, the first thing that I'll need to do is add some water to a beaker. Now the next thing that I'll need is a super sneaky chemical called hexamethylene diamine. I'll add about 4.4 grams of it to the water, and I'll stir it until it all disappears. It's now all gone, and I'll move on to making the other solution that I need. This one's also pretty simple, and the first ingredient is something called cyclohexane. I'll add about 100 mils of it, and then I'll pour in the last ingredient called adipoyl chloride. I'll mix this up a bit, and now I'm ready to do something nasty. To do this, I need to add 10 mils of each solution to a small beaker. I'll start with the stinky water-based one, and then on top of it, I'll carefully pour in the cyclohexane one. These two liquids aren't able to mix, and like water and oil, they stay separated. Now, all I need to do is use some tweezers. I'm able to pull out a gross slimy string, and if I wrap it on a glass rod, I can keep pulling it out. I really find that this looks pretty nasty, but it's actually just plastic. More specifically, it's nylon, and it's forming between the two liquids. I can keep pulling it until the chemicals run out, and I'm left with something that kind of looks like a cocoon. It's still full of water and cyclohexane though, and it's all soft and squishy. Now if I try pulling it apart, it's not actually very strong. This is because all the fibers are extremely thin and fragile. If they were a lot thicker though, like they are in clothing or in a fishing line, it would be a lot harder to do this.
О, кули. Блин, так приятно. Видишь, если играть нормально, тогда надо. Ну вот это. Вот это наоборот. Это он о себе так думает. Ну это он имеет в виду. Ну, нет.
Делитесь знаниями и опытом. Если в интернете все давно написано, почему мы продолжаем задавать вопросы специалистам?